This lesson is going to be dedicated to understanding how a 3D printer actually operates so that our designs will print effectively. This is a highly sped up time lapse of an object being printed in a MakerBot machine. What you'll notice is that it prints from the top, and this is going to be a big key to designing. It prints and prints and prints layer by layer, layer by layer, using a piece called an extruder from the top. So everything goes from the bottom and it builds up and up and up and up and up. We're also going to learn about design constraints, such as things called overhangs, where parts hang over the surface of the design plate. If you can eliminate overhangs altogether, though, that is the best option without having to worry about the after effects. When you get into After Effects, we can look at things like an X-Acto blade. This will help us cut away some of the stringiness. And then once everything has been removed, then we can take something like sandpaper and sand it down to a smooth surface. Another design constraint that we have is the overall thickness of the things that you have in your design. Our printer is pretty awesome. It can print at a scale of 0.4 millimeters. Okay, and looking at these examples down here, it sort of shows you 7 millimeters, 6 millimeters, 3 millimeters, and we can go much smaller than that. We can go to a 0.5 millimeter. This is incredibly small, but I've had students design things that were even smaller, and they can print poorly when you design that small. This is the design created by a student that I had named Ben. It's a pretty awesome design when you really look at it. But where he really ran into trouble was at this front gate. The level of detail that he included on that on the computer looked absolutely gorgeous. But when we got that out and actually measured it, grabbing a tape measure here and seeing what that was actually at, these measurements are going to show in inches right here, and that says it is less than 1/16 of an inch. In fact, when those pieces got printed, they did not turn out very well at all. So here is Ben's project as it was printed, and you can see all of these major problems that we had because his designs and details were so small. You look at what happens to his gate here, and as beautiful as it looked on the computer, this was the result that happened. Same types of things happened on the tops of his designs. If you remember back to the video that you just looked of his design, there were flags up on top, and he had different details at the top. We can see what happens here. The flags didn't print at all, which is another problem that we're going to look at here. So let's have a further look at what overhangs are. We're talking about if we have a part of the surface that literally extends above the build plate with nothing underneath it. So we can see this is an overhang test. The longer the overhang, the worse the stringiness becomes. The longer the overhang, the worse it becomes. The longer the overhang, the worse it becomes. If you have an overhang, but if you increase the degrees to 45 degrees, then your object will print accurately if we can get that up to 45 degrees. Anything less than that, it will not. Anything more than that, and you're okay. Here's a picture of what these supports do. So if you have an object, this was the object as it was designed, which has a lot of overhangs. The chin, the face here, down to the chest, and then we have what would be called bridges underneath here. When it's printed with supports, it puts in these materials which can be broken away after your object has been printed. The after effects for it, for these objects with the arm hung out, you can see the types of stringiness and things that happen to your print when it is printed with an overhang. The supports are here and can be broken away, but then we've got to take a lot of different materials when you get into After Effects. We can look at things like an X-Acto blade. This will help us cut away some of the stringiness, and then once everything has been removed, then we can take something like sandpaper and sand it down to a smooth surface. If you can eliminate overhangs altogether, though, that is the best option without having to worry about the after effects. Using letters as an example here, we have the difference between overhangs, which would be this. The Y also has overhangs, and then the H, this center part right here, would be called a bridge. We have an anchor point over here and an anchor point over here, and the extruder can quickly manage this bridge. When it is just an overhang, there is no other anchor point on the other side. So this is simply just an overhang and not a bridge. Looking at the printed results of these, you can see how stringy the underside of the T gets. In fact, this bottom corner does not get printed at all. You sort of have this upper angle that happens on both sides and a lot of stringiness underneath it. The bridge here on the H made it through decently, but we do have a little bit of stringiness as a result. But then you look at the Y with the 45-degree angles and everything prints just fine. So a successful bridge must be across the same layer, exactly horizontal. It must be a straight line. Curves do not work to create a bridge. And the maximum gap would be approximately 2.5 centimeters. If you go longer than that, then it is a really, really hard gap for the extruder to take. When the gap is too large, the bridge will begin to sag. In this example over here, you can see it's a cone shape. And when it's printed on its side like this, the entire side of it here becomes an overhang and it would require supports. But if this object was simply turned upright, like this example here, then it is printed with no overhang whatsoever. The print starts at the bottom and it goes up layer by layer by layer, and there is absolutely nothing that hangs over the top of the surface. To have a look at that with a student example, as it is right here, we would have to deal with lots of overhangs. We have an overhang on this side, an overhang on this side, although the angle that it's at would probably print just fine. And on the inside of the design in here, we would be suffering from a lot of sort of bridges. Now, if it was printed in this orientation, we would probably have to do after effects of sanding and things. However, if we simply turn this so that the object is printed flat down like this, if you'll notice, it would print layer by layer going up and up and up, and there is nothing that hangs over the surface anywhere. So orientation is one of the best solutions you can have for your design. That's it for today's lesson. I hope you have a firm understanding of the constraints that the 3D printer puts on us so that we can make good, solid designs. Thank you.